Mesopotamians began to build the ziggurats. Ziggurats are pyramid-like towers representing the celestial bodies: Sun, Moon, Mercury, Venus, Mars, Jupiter, and Saturn. The job was to keep track of the yearly cycle. Egyptians. The Egyptians' emphasis in astronomy was different from the Mesopotamians. Egyptians made temples and monuments to respect the cardinal points north, south, east, and west. They used astronomy for practical purposes, developing the calendar to be used to predict the Nile flood. Stonehenge, the world's most famous prehistoric monument, has several stages. The first monument was built 5,000 years ago. The unique stone circle was built in 2500 BC. Chinese made and recorded observations of eclipses in the 13th century BC. 900 solar eclipses and 600 lunar eclipses were being recorded carefully 2,600 years ago. Thales, the first person to use the Little Dipper as navigation. The Little Dipper contains the North Star. The Big Dipper was used for navigation since the Little Dipper contained the North Star and it moved less overnight. He was able to determine the height of a pyramid using the length of the shadow. He predicted the solar eclipse in 585 BC. Pythagoras developed model for the solar system included two features that marked a permanent break from the previous thinking about the universe. Babylonians. By 500 BC, the Babylonians were able to use the long record of observation to see regularities and patterns in the motion of the moon and planets. Aristotle was a student of Plato, just like Exodus. He argued that all the celestial motions must be circular because circular motion is the only kind of motion that can be repeated forever. Aristarchus. He applied geometry to the study of astronomy, showed it's possible to use geometry to find the distance to the moon and the relative distances and sizes of the sun and moon. Eratosthenes used geometry to calculate the size of the Earth. The difference in the noonday altitude of the sun is the same as the difference in the latitude of the two places from which the sun is being observed.
Arcus improved and carefully carried out the method of Aristarchus, found the distance of the moon to be 59 Earth radii. In 134 BC, Hipparchus discovered a new star that is one that increased in brightness enough to become visible to the naked eye. Mesoamericans flourished in Mexico and Guatemala between about 1,000 and 2,000 years ago. Many Mayan monuments and buildings were aligned with the position of sunrise and sunset. Venus was identified of more important gods and cultural events with time to coincide with particular positions of Venus. Worked in Alexandria from about 127 AD to 151 AD, was the last of the great astronomers of antiquity, made completion of a system that could accurately account for the motions of the planet using the combinations of regular circular motion. The Islamic astronomers improved many observing techniques. They also proved the ways in which planetary positions were calculated and made many Arabic names for the stars, also translated the ancient work of astronomers. Nicholas Copernicus lived from 1473 to 1543 and proposed the first fully developed heliocentric model by putting the sun at the center of motion, all motion in circle. The annual motion of the sun against the background of the stars is caused by the Earth's annual orbit around the sun. Brabe, while a law student at the University of Leipzig, he sneaked out at the night to observe the night skies while his tutor was slept. At 26, he wrote a book describing his observations of an extremely bright new star or nova. Galileo. Before Galileo observed the sun and the moon, they and other celestial objects were generally thought to be perfect and smooth spheres. Galileo found that the moon had mountains and valleys through 1564 to 1642. Kepler's first law of planetary motion states that a planet moves on an elliptical orbit with the sun at one focus. A ellipse is a closed curve for which the sum of the distance from two fixed points. Sir Isaac Newton, who pulled together the scattered ideas and discoveries about motion and gravity. The fundamental descriptions and explanations for the motion of objects, whether terrestrial and celestials, is contained in Newton's third law of motion.
Computed the orbit of the Halley's Comet. In 1676, he visited St. Helena and set up a observatory with a large sextant with telescopic sights to catalog the stars of the southern hemisphere. Developed the general theory of relativity, one of the two pillars of modern physics, along with quantum physics. He's best known for the mass-energy equivalence formula. Developed the Bohr model of the atom, said that electrons are discrete and that electrons revolve in stable orbits around the atomic nucleus but can jump from one energy level to another. One of the pioneers of quantum physics, nominated by Einstein for the Nobel Prize in Physics in 1945, he published a paper on Einstein's theory of general relativity. One of the key pioneers of quantum physics, in 1927 he published his uncertainty principle, upon which he built his philosophy and for which he is best known for. 1932 he was awarded the Nobel Prize in Physics for the creation of quantum mechanics. Known for showing that the recessional velocity of a galaxy increases with its distance from the Earth, implying that the universe is expanding, and that is called the Hubble's law. The first to propose the theory of expansion of the universe, discovered 2 years before Edwin Hubble, he proposed the Big Bang theory of the origin of the universe. The father of the atomic bomb, for their role in the Manhattan Project, they developed the first nuclear weapons used when bombing Hiroshima and Nagasaki. Known primarily for the theory of stellar nucleosynthesis, rejected the Big Bang theory and promoted panspermia as the origin of life on Earth. Accidentally discovered cosmic microwave background radiation in 1964. Major development in modern cosmology, was discovered earlier but was the first American radio astronomers to discover it.